will introduce our final speaker of the day. You ready to roll? Wonderful. Okay. Mapping drones in agriculture. Warren Genik brings over a decade of expertise in agricultural drone technology and precision mapping, having pioneered UAV applications in farming since 2014. With a strong foundation in software development, he successfully bridges the gap between cutting-edge technology and practical agricultural solutions, addressing critical challenges faced by modern farming operations. Warren's work demonstrates the transformative impact of combining software engineering expertise with agricultural domain knowledge, delivering measurable ROI for farmers' operations throughout innovative technology solutions. So please join me in welcoming Warren Genik.
Good afternoon. Thank you very much for joining me for some information on my experience and my adventures in mapping with agriculture. So my name is Warren Genik, and I'm here to talk to you for the next few minutes here on a few things. But just first, a few things about me. So I'm from Swan River, Manitoba here, so not too far away. I've lived there for a number of years, really enjoyed the area. And I am the co-founder and chief technology officer with Green Aero Tech. So we're a company that's based outside of Winnipeg and handling a lot of things with drones and agriculture. Myself, I'm also personally a full stack developer, so I really like to get into the core of the data and the programming and the development of this stuff. But on the drone side, I have completed close to or just over 5,000 UAV flights in my decade of working with drones. So it's kept me very busy, kept me entertained for sure. I'm also, I consider myself a data hoarder as well as a tech nerd. So I'm going to try to keep this from getting too crazy on the details of the technology and stuff. But it's something that I really do love talking about for sure. Also interesting, so with my experience with drones, I've also gotten my parents into it. They've worked for me as drone pilots, and now my sons are in it. So I'm now part of a three-generation drone pilot family. So I think that's pretty cool. So yeah. But now, speaking of drones, I want to start off with just a little bit of a history of the evolution of drones and where they've come from, and then we'll talk specifically about how it's affected in agriculture. So as early as 1987, there's been these unmanned flying machines. So Yamaha from Japan has started with their R50 unit, which really could be kind of considered one of the very first drones. But there's a lot of military technology that's crossed over into the consumer space, and this was also really accelerated as GPS became a lot more common and allowing for control of the drones. And so then you start to see these big companies expand and start off with. So DJI, something that most of us are very familiar with, started in 2006, and they really offered the first consumer affordable drones that were available that weren't do-it-yourself kits that you had to really have a lot of technical expertise with. And so the Phantom 1 was kind of a revolutionary model that came onto the market in as early as 2013, and it really set the stage for consumer drones and drones in being beyond just in movies or sci-fi kind of thing. Then in 2013, also the SenseFly EB. So one of my favorite drones that I've used over the years was introduced, along with a whole suite of sensors focused around, and this is where we start to get ag-specific, but multispectral, and we're going to talk about that a fair bit today here. In the US, they started to actually recognize that, you know what, hey, drones are flying around, so we need to have regulations around them. So that's when you start to see actual regulations and governments recognizing drones and setting up rules around them. Finally, as we come into this current stage of technology, here's where we now start to see a lot of refinements around the precision. So we get RTK and these kind of technologies that really expand what the capabilities are and take it to the next level. And then, of course, we have AI that is really starting to talk about, you know, how do we properly take all of this data and turn it into usable information. And so Canada as a whole as well has been actually really on the forefront of the rules and regulations around drones. So maybe a little bit later that some of our regulations came into place, but they've actually a really robust framework. We'll talk a little bit about that as we go. But it was also interesting to see that Western Canada, because of the wide open prairies and the broad acre access there, meant that when it came to mapping and agriculture, we really had a lot of opportunity, and we took that and became kind of leaders in some of the technology and some of the ways we're using this information that's available now. And if we look at the industry as a whole, we saw that drones, they suddenly became, you know, a big market. And the cool thing is that a huge part of that market, especially beyond the consumer side, was actually focused on agriculture. And so as the market became more viable, agriculture is a focus of that. And that's what we're going to talk about a lot today here. So here we have, like, just thinking about how the agricultural market has been revolutionized from this. And really, it comes down to saying that this drone mapping puts field-level information available in farmers' hands directly, and so that you can make decisions based on actual data and not just assumptions. So not just looking at and making guesses or anything like that, but have actual reasons behind your decisions there. And so this meant that we could do early problem detection, so looking at and seeing things that are going to be a problem before they maybe are visible, because we can use these drones with different sensors. Then also, because we can be precise, we have GPS, we have RTK, we can be very precise in how we apply inputs and put them only where they need to go, because we have all of this information available. Water management becomes a trivial thing, because now we have these tools that can do 3D modeling from your drone. And ultimately, we can do all of this year over year so that we can get long-term tracking and really see a change or a change over time. And that can be a valuable tool just in itself by just seeing that trend and what's happening on our land. So talk a little bit about how the drone mapping actually works. So the first step is to plan out where you want the drone to fly. And so there's software that's designed to do this, set the boundaries, set all of our parameters and settings. And so there's a lot of different things to be set, but for general flights, we're going to fly at around that 400 feet in most cases. We want to have some overlap between our sidelines and front overlap, that kind of thing. So when we go to do the actual data capture, all of it can be automated. So the drone just flies by itself, it captures these images and collects them all. But we have to do something with those images, so that's where the processing side of things comes in. And so we need to use special software to take those hundreds or sometimes thousands of images, merge them all together in a special way, and actually be able to extract some usable data out of it. And when it comes to that, that's what we're looking for, is these actionable maps, something that is actually telling us information from the data. So this could be vegetation indices, so we'll talk about that, elevation maps, or ultimately prescription rate files that are going to help us change or use our equipment more efficiently. And so depending on the type of mapping, if we're doing simple RGB mapping, we can do that quite quickly and cover quite a lot of area in a short amount of time. But then as we get into more complex sensors, it might take longer because these are higher precision, they take more work to do it. And same with the processing. So there's a lot of different processing options. Once you get the data up into the cloud, you can utilize very high power servers and process data in as little as minutes. Or we can do that locally, especially if we're rural, we don't have good internet access to get into the cloud. We can do that, but it might be overnight or take some good computing power in our laptop or our home computer sort of thing. And then now there's even some technology that we can do it in flight. We can actually see some insights on our field in real time with NDVI, this kind of thing. So when it comes to one of the key things that people think about in agricultural mapping, it's multispectral has really been a key thing. And so this is where we're using near infrared and light that is not necessarily visible to the naked eye, and we're able to look at and see what the plant is doing health-wise. And the reason this is important is because plant stresses can show up on this near-infrared spectrum quite a bit earlier than what we might be able to see with our eyes in person. So it means that we can catch something early and ultimately take an earlier action and correct that problem or help out in that situation before we go there. So ultimately what it means is a healthy plant is going to have a different type of reflection than an unhealthy plant. And so near infrared is one of the key things that we're going to use to be able to see that, that kind of a difference in the plant, where visually in the spectrum that we can normally see, we might not be able to determine that, or not until much later in the stage. So when you're talking about multispectral, you're also usually talking about some kind of a vegetation index. So NDVI, Normalized Differential Vegetation Index, this is a very common one probably what most people are familiar with. You might, if you've been farming for a while, you've probably seen some kind of a map that's related to this. But there are other indices as well available. So there's the red edge index, the green NDVI, these other kind of tools, and they look at different parts or different combinations of those light bands of reflection. And so most drones that are collecting NDVI or near infrared, they can do some combination or all of these different bands. And so for those that are experienced in it, you might be able to find different times of the year of the crop growth season where the different bands are going to be more useful. So, and again, this is all, it's going to vary between different crops and different applications or different stresses as well as to what's going to be the most useful. But in general, there's going to be a good indicator through one of these type of indices. So once you have that, again, the whole idea is that we're able to see problems sooner rather than later and be able to actually start treating them much sooner. So we can also, because we're doing this across the entire field, not just what we can see within where we're standing right now in the field, we can see patterns start to arise, and we might be able to identify from those patterns, again, another source of where this problem is coming from. So it might be a nitrogen deficiency, it could be too much water, too little water, so a drainage issue, all these kind of disease pressures or different damage things, and pest infestation, all this kind of stuff. So again, depending on what stage your crop is at, you'll be able to learn different things depending on what you do. So ultimately, the idea is to be able to fly or use your drone at certain times consistently, maybe multiple times throughout the growth season, but also maybe at the same time through multiple years, so that you can help to really establish and see long-term problem zones. So maybe something that's related to compaction or to other drainage issues, anything like that. These kind of patterns will start to emerge, and because we're using drone imagery, it's something we can do, and we can have archival information that we can look at year over year or season over season and really start to gain some of these additional insights. Ultimately, maybe what we want to do is we want to get to this variable rate application, so where we take all of this information that we flew from the field and generate into a map, and now we're going to classify it, and we're going to start to look at turning it into different zones and maybe applying different ratings to each of those zones, so a low, medium, high, and maybe actually work with it to put it into some kind of a application map. So maybe a different rate for this zone comparatively, because that's now information that we can take out digitally and put into our farm equipment. So whether it's our tractor for like a John Deere with an ISO XML format, allows us to control that equipment there, or even to like a spray drone now, because that's a big thing, is being able to look at and send the drone or the tractor or whatever the equipment is to only the specific areas it needs to go, or turning the rate up and down as it progresses. So there's really a lot of different ways we can utilize that. So whether it's seeding and getting the low population areas, whether it's working where there's obviously fungicide or fungus type stresses, that kind of thing, and even just nitrogen fertilizer and preparing the soil better that way. So typically, you can actually do a savings on your crop inputs by using this kind of variable rate application, and it can be significant numbers at the end of the day, depending on your operation, for sure. And so ultimately, again, you want to really be able to use this for longer term benefits, because it comes down to the yield is what you're wanting to affect. And so by using all of these different layers of data that are available to you, with drone being one of the very first steps usually, but also combining that with your yield monitor, looking at your soil sampling. We just had a great presentation on the soil side of things as well. But also looking at what we actually applied from this year or prior years, and then combining it even with elevation maps. This has all become something that we can really predict better what our ultimate yield is going to be on that field. And we can test it year over year and see where are we right, where do we need to tweak things, where do we need to get more information, or all of this kind of things. Because this variability can show up all throughout the year, but we can have an idea of what to expect by harvest time when it comes around there. So when you are using this data, there should be a few key questions that your data should be able to answer. So Are your low yield zones, are they consistent year over year? Could it correlate with drainage patterns? And ultimately, is there ROI that is there to make it to remediate this? Is it worth the money to fix this by changing your inputs, by changing your farming, something like that? So it's a really powerful tool, and it starts with drone data, drone mapping. So that brings us, as we onto kind of the second part, or the second thing that I especially am passionate about with the drones, and this is when it comes to water management, because water management is a very important part of any farm practice, whether it's too much water or too little water. Drones will be there to help you to determine what the problem is and where it is specifically. So it can be, because it will affect your yield, it'll delay things if it's too wet on the field, and you need to calculate out if it's worth putting in something like a tile drainage system or to do surface drainage. What's the cost? What's the ROI going to be on that? So when it comes to the drainage mapping side of things, this is where photogrammetry is the technology, or one of the main technologies to be used here. And so photogrammetry is taking all of these 2D images or pictures that have been taken from the drone, combining them together into a 3D model that is able to use for elevations or other types of hydrological maps created from there. And some of the key outputs that you can get, so you can get digital elevations model, DEM, so that's where we were talking about a bare earth model and really the kind of the cleanest type of a model as possible. In most cases, however, especially with drone photogrammetry, we're usually dealing with what's called a digital surface model. So this is where the canopy is included, because this photogrammetry process only works with whatever's closest to the camera, which if there's standing crop, that means we're going to be looking at the top of the crop. If it's bare ground, then we see the bare ground. Once we have whichever underlying model, now we can start to do the analysis. So whether it's contour maps to just look at what those elevations are across the entire field, or doing slope analysis and seeing generally what the layout of the land is, or getting more specific and seeing where sinks and depressions are. And we can be very specific to very small areas, identifying these sinks or depressions and what's going to hold the water in longer than it should or longer than we would like it to be. And then looking at the natural flow paths. Where does the water want to go based on gravity, based on the topography, and how can we maybe help it along its way? And so when you're doing any of these kind of products, you want to take into account what is the accuracy. And so that's really going to be determined by the type of drone you're using. So if you're using something that has PPK or RTK, like a high-grade GPS available, you can see, in some cases, get that 5 centimeter or better resolution or accuracy, so sub 2 inch in some cases. If you're working with just standard GPS, it's going to be a little bit more because those satellite systems aren't as accurate just on their own without the RTK. Now, why it matters which way we're using it. So again, it's easy to see that water flows downhill, but when we want to get into the specifics, we have to think about what we're looking at it with. So with drone photogrammetry versus public LiDAR or satellite, they're both very good options in a lot of cases, but we have to remember that with satellite or shuttle radar mission data, it's going to be relatively coarse resolution, so up to a meter or more that we only get 1 point. Whereas with the drone, because we're flying at only a few hundred feet from the ground, we can get points literally every 2 inches or even 1 inch across your field. Way more data than we actually want to look at, but it means that we can identify micro-topography and really tiny little areas there and be very specific. Also, when is that data available? Well, with drone, you can fly it on a good day and get the data that's going to be up to date up to just a few minutes ago. Whereas if we have to rely on satellite or a LiDAR collection, it might be years old or maybe at least months or weeks with satellites that might not be as relevant to what we need to do today. So again, just making sure that when we do use the drone for this, that we're doing it at the right time of year and using the right kind of settings. And this will give us really good results, even with relatively simple technology that doesn't have to be overly complex. Now, that being said, if we want to take it to the next level, this is where LiDAR becomes very interesting. So LiDAR stands for light detection and ranging, and it's hundreds of thousands of laser beams being fired out from a sensor every second, and as those beams bounce back to the sensor, they become elevation readings, and they can read the topography. And the really cool thing is that unlike photogrammetry, these LiDAR pulses can actually penetrate some levels of vegetation. So it means that they can see through grass and through standing crop and see the ground below, so you can get a true, that bare earth model is going to be available to you. So if you need to do a flight and you need to collect some data and it's, there's crop on the field, LiDAR is going to be a much better option than the photogrammetry. If you're dealing in forests or treed areas, again, LiDAR is going to be able to get past the tree, the canopy, and see the bare ground below, and we're going to be able to get a good picture of what's going on there. Same with grassy ditches or waterways, it's going to work a lot better that way. Now, the big concern, though, is LiDAR is typically a lot more expensive when you're talking about the sensors or the equipment that's required there. But you can use, it's going to be survey grade. It's a 1 centimeter accuracy in some cases when it's done properly. And so you can do that through a lot longer seasons, so maybe into the winter time even. But again, bear in mind that neither of these technologies are going to be able to be very effective at going through snow or standing water, so those things are never going to give you a good reading under most conditions there. So in general, photogrammetry is a very good cost-effective solution, an easy way to get your elevation information, but LiDAR is a really good option, especially when you're tight on time or you need it at a very specific. It's a premium option, but it will get you very good results at the same time. So the next thing is drainage analysis and looking at that data, and how do you do that? So there's a lot of tools and things on the market that are GIS packages or geographic information systems that require a lot of knowledge and know-how on how to operate this software. There's university courses and degrees in just how to run GIS software, so it can be quite daunting in some cases. But at the end of the day, really, you don't need something that does a million different things. You want just a few specific things. So myself, what I've done over the last 10 years is I've developed a system that allows us to take in imagery from drones, turn it into basic elevation models with some watershed modeling on it, and then turn it into something that a farmer or anybody with a browser can take a look at and start using the data. So, and turn these into visual reports that are very easy to understand and ready to actually be used. And so the system that I put together over the 10 years, it's actually been used by over 500 different customers and clients, and actually we processed close to 2 million acres through it. So it's been well tested, and it's been pretty cool that something we've used for a while there. And so if this video works here, I'll try this here. There we go. So this is going to take us through just a quick overview of the program here. So you log in, you choose your map. As you can see, it starts by taking you into your actual visual view, and you can see that you zoom right in. This has got the high resolution pictures there, but from that is what's generated all of this elevation. And so as you zoom out, you can look and see where, as you move the mouse cursor back and forth across the screen, up at the top left there, you see we're getting a real-time elevation data from that. So I can check anywhere on my field and find out what the elevation is. And then from there, we can start to do our drainage analysis. So we're able to pick and choose and look at where our sinks and depressions are. That's represented by the orange and red. And then we can click on one of these lines, and now we can get an elevation profile, and we can see along that natural flow path what is the water level, or what was the water want to do. And you can see these orange or red areas here highlighted here, and that's where water is getting held back maybe in a depression. So in wet years, that's going to be a wet spot for a week or two longer. And so when we look here, we actually get a calculation and says, oh, we need about a 2 or a 5-inch cut to go through there. So we're not changing the path of the water necessarily, but we're able to make a few small modifications to our field, and we can get it cleaned out and running again. So now we can demonstrate here just what one customer did with this information here. So we gave him this map, and then we mapped it again, and now we can see where all of his scraper lines are. So you see that he followed fairly closely to the flow paths that had been identified through our system here as he went through. And then when you turn off the before, this is now the after of those sinks. So his field is going to be far better draining for the next year, the next wet year. And so he's going to get a lot better drainage. He's going to be able to get onto that field a lot sooner. All of that from that one initial map, because now he went out and followed those lines with his scraper. And so it makes a huge difference, and that can be immediate ROI for somebody. So if you invest in a drone and you collect this kind of information, this is now the kind of things you can do with it. So in our tool here that we have, we can, as simple as you select a few lines, click on the Save button, change the color if you want. So you want to identify that, oh, we're going to do the red line today and the green line tomorrow, whatever. Now we can go and we can export that, turn that into a shape file or a KML file. That can be exported out to our tractor display so that now we can get onto the field, we can follow that line with our scraper or whatever the case is. So a very simple system, and just within a matter of minutes you can start to get that information and then get out into the field and do the work while the getting's good. So when it comes to using drones, you've got a few different options. So yes, you can do it yourself. You can buy a drone for as little as a few $100s. It's great if you want to be going out doing some scouting, checking on crops, this kind of thing. You don't need to have an expensive drone to do that. Yeah, maybe there's some software requirements, some things like that. There is going to be some training, but most of that can be all self-taught. There will be some licensing depending on which drone you buy. If you buy one that's more than 250 grams, you're going to need to have a basic drone pilot license and pay a $10 registration fee for that drone. Or if you buy a drone that's larger and you need something more specialized of a license, you're going to need your advanced drone pilot license, and you might need an SFOC, which could be $1,000 to go through that process now. But those are options that you can do. Now you can go to the next level. So if you've got a big farm or you're wanting to do a lot of drainage and elevation mapping, well, now you can get a RTK capable drone like the Mavic 3M, and something like that is around that $6,000 to $8,000 depending on how you load it out. You want to add in that RTK base station so you can maintain and get really good accuracy. And then there is software to do that processing. There's going to be a cost to that as well. So again, it's going to cost you more, but you're going to get much more capability and much more results from that equipment. So, and then the other option is hire somebody to do it. Now with drones being so common, there's a lot of people that have started businesses. That's how I got started into things, and charging a few dollars per acre depending on what the mapping was. Get out, have somebody come out there, fly your land, and see what you can learn from it. If you like it, maybe next year you can get your own drone and do the rest of your farm with it. So really a lot of different options there. It's just, you got to start somewhere, and sometimes just hiring a service is the way to do it there. There we go. So I often get asked, where do I think drones are going? What's going to be new? What's going to be the next thing coming out here? So I'm particularly excited about the idea of gasoline hybrid drones. So there's a few on the market now, not many in the consumer space specifically. But what these are drones that have a gasoline engine built into them that generates electricity, and then the electric motors are still so you still have the flexibility of an electric drone in the terms of control, but you have the fast filling capability, the high payload capacity because there's a lot of power available on board. And so you can get many hours of flight time out of them sometimes because of the energy density of gasoline versus our current battery technology. Then the next thing is hyperspectral. So we talked about multispectral and being able to see plant stresses. Well, hyperspectral is another form of sensor that instead of looking at just the near infrared, we go well beyond into the invisible spectrum, and we can actually get spectral profiles on plants, on minerals, on all kinds of different things. And so we can now start to identify specific nutrient deficiencies. We can do disease detection. We can do actual identification of the weed, not just that there's some, a healthy or an unhealthy plant. So it goes well beyond what multispectral can do. And then finally, with drones and AI, thinking about that, well, talking about having drones working together. So the idea of being able to have multiple drones work together and work on a single task altogether to cover a lot more area in a short period of time with a lot less operator requirement or interaction there. Some really interesting things. One of the things that's really held back a lot of development when it comes to swarming is the fact that in China, in USA, in most of Europe, it's very specific that one drone per pilot. That's how the rules are all set up. Canada, we're actually very unique here in that we have legislation already in place with even a basic pilot license that if you're using a drone designed for it, you can fly up to 5 drones from one control station. So it's very interesting to see that, and so I think we're going to see in Canada specifically, we're going to see a lot more development around that because our legislation is already far ahead of what's available in some other countries, and so that's why they're not focusing on it as much because they don't have the rules to support it. So, I mean, it's feasible that we think about a farm that, you know, we've got these hybrid drones that are swarming around, they're constantly monitoring the fields, and then they automatically send out a message to another set of drones to actually go, and because they recognize that there's a pest infestation happening, and it starts to deploy these other drones, and they go out autonomously and start to actually spray or treat that field. And all of this while you just simply are working on in the shop and monitoring it. So you know, that's my dream of the future when it comes to drones in agriculture there. So. But yeah, that brings me to the end of my information there. And yeah, so again, thank you very much for taking the time to listen to me here, and yeah.
Oh, there it is. Okay, hi. If anybody has any questions, that was so, that was excellent. I just find drones fascinating. I think the future of them has a lot of potential to lower labor and increase efficiency. So do we have questions, comments on the content? And again, I'll ask that you wave your arms like a lunatic because I just have a blinding light in my face right now. Oh, I see a not quite lunatic level wave, but yes. We got a microphone coming for you.
Hi, I was wondering about hyperspectral. If I wanted to pick out like a wild oat map where they are in the field, how high would you have to fly to get that resolution? How long would it take to map a section?
Yeah, so with the hyperspectral technology, definitely the tech is there. The big issue right now is that it's very early on in that side of things. So in the multispectral range, it is possible to do that by just picking it at the right time. So I think you've said wild oats, yeah. And so I've done an experiment with that before where it's as simple as those are the first thing to come up early on in spring. So we do a map and we see where is all the vegetation early on in the season, which is the wild oats. And then we record that, and then maybe later in the fall we do an Avidax application or something like that on just those areas. And so by timing it right, you can do that with the technology that's available now. Yeah, absolutely. Yeah.
Anybody else? Going once? Twice?
Oh.
Oh, there we go.
Sorry, I didn't see you. Yeah.
Hi. One of the limiting factors with drone application, let's say for pesticides, for instance, in field, in crops, is the availability, the licensing of those products. So I'm not sure where it's at, but there's probably quite a bit of work to be done on that, but I'm thinking it's going to catch up sometime. So what do you think the timeline might be on some of that?
Absolutely, yeah. So yeah, because I mean I'm very much involved in the spray drone application side of things as well, and that is probably our biggest friction point because in the U.S. what they're doing is the EPA and the FAA, they got together and they said, you know what, spray drones are just another form of aerial applicator. So anything that's already approved for aerial application on the chemical side of things is good to go for drones. Canada, they said no, we want to see specific testing around drones specifically there. So that means that there's the companies that are working on that, they do have a lot of research and information to gather. I've worked on some of those research projects, and so I've been able to do some of the testing or do the flying for the testing. And so, yeah, so I do know of several products that are far down that line and are very close to becoming on label in Canada. And then, yeah, so I am personally confident that this coming year we're going to see a lot more things changing. And we've even had information rumored and some confirmed that Health Canada is actually looking at going more to like what the US did. So they've seen enough research that they're getting ready to hopefully at some point, now they don't have a timeline on it, but some point say that yes, if it's aerial application, drone is another form of that, and we're good to go. So I'm personally very confident that it's going to be happening very soon in the next less than a year is my guess, but yeah.
Thanks, Warren. I'm getting into the ag tech space only now. Like I'm taking a course in agricultural technology. Where would you advise me to concentrate or focus on based on what you've seen and where the sector is heading? Thank you.
Well, that's a good question. So again, the hardware technology to get a drone and a camera into the air is very well in place already. What is, I think, is still needs work or still has a lot of opportunity in is on the software side of what do we do with that data to turn it into information. So that's where, you know, AI is, for better or for worse, AI is here and is coming. And so I think there's going to be a lot more advances that we're going to see with that. Because we have all of this all of this data available to us. It's just streaming in from all of these sensors and stuff. But on the software side, that's where still properly analyzing it, properly turning it into information that is going to make a difference for me on my farm. That's where I think we still need to, you know, there's a lot of opportunity there. So software is ultimately what I would say.
Excellent. Yeah, there's no point collecting data if that data can't be analyzed to
Exactly.
make informed decisions, right? So last chance for questions, and if I see you waving, I will get to you for sure. And while we wait, in case there are questions, again, CEU credits for this session, I believe it's 1 credit. So again, along the concourse, there are papers. You can sign up for that if you are collecting those. And I just want to thank Warren for his wonderful presentation. The Ag Days Committee this year, in lieu of speaker gifts, has elected to, in honor of our speakers, make a donation to the Manitoba Farmer Wellness Program. So that is our thank you for that. And if there are no more questions, thank you so much, and we really appreciate your time, effort, and energy. We'll see you tomorrow back at Ag Days. Thanks, everyone.
Thank you very much. Thank you.